Well, hello and welcome YouTube, Mr. Robinson back here with yet another brand new exciting video that is all math-based, of course. And as always, it is an honor and a privilege to be serving you here, as it is every day in my virtual classroom. Step inside, look at some stuff in the background while I talk to you for a second. This is Integrated Math 1 material. My last two videos were on Integrated Math 2. I did a Unit 1 review and a Unit 1 practice test. This is going to be just one video for my Math 1 kiddos here, Unit 1 practice test, and the topics of conversation right here are quantitative reasoning from Module 1, and then algebraic models from Module 2. Now, what does that stuff mean? There's going to be a lot of solving for x. There's going to be a couple word problems here and there where you either got to set something up and solve it, or you got to identify what those terms mean. These things even break down into, like, what does an expression mean? What does a term mean? Can you identify the second coefficient in this expression? Different things like that will come into play here, and it's kind of scattered. I'll kind of help you out with that along the way as well, but I just wanted to let you know that this video could run in the longer end. There are 21 questions. Okay, there are 21 questions, and because there's only one video of this case, I'd rather do more of the teaching than just the doing. That means I'm not just going to run through the example. I'll talk about kind of what we're doing within there. I'll build up as I go, so if there's another problem like it, maybe I won't spend as long on it. I'll consider alternative options and why you don't do this, things like that. Because there's only one video, only one review video I'm doing for my Unit 1 kiddos and for anyone else who's watching. You might have the same exact book and you might have a test that'd be similar to what my kiddos are going to be facing when it comes to a test. So, what do I want to say to that? So it's going to be a little bit longer on that end with the teaching. Now, there are 21 questions. Okay, there are 21 questions, and they're a bit scattered. What I mean by that is I don't start from questions just from section 1.1, and then it goes on to 1.2 and 1.3 in that order. You might have questions from section 1.1. It might be the first problem, but then it's also the 16th problem, for example. Or you get a word problem on question 3, and it shows up again on 10 and 11. So, you know, it's a little scattered. Okay, so the way that I want to help you with that is by the description section below. I will provide a PDF for this practice test, which the practice test, by the way, for me, for my kiddos, is going to be a lot like their actual test. But description section down below, PDF of the practice test, as well as timestamps for the problems in order, 1 to 21, and then I'll have other sets of timestamps for actual topics of conversation. If it's about word problems, I'll say word problems, numbers 3, 10, and 11, so you know how to go in a certain order to kind of help yourself if you think that it will help you, especially if you have this book. I didn't write this practice test. I haven't even done the problems on it yet, so I'm going to do it with you at the same time. So let's go ahead and get started, all right? So starting with this guy here, we're going to start with problem number 1 and 2. Find the value of x for both of these. -1/3 x equals 20. Okay, so I'm just going to rewrite this right now, right here. And let's talk about this in a couple ways. -1/3 x equals 20. Number 1, -1/3 is the coefficient in front of x, and it is multiplying with x here, okay? It's multiplying. So you can treat this in two separate formats, and I'm going to show you them in two separate ways. One way is if I literally multiply -1/3 with x, and to kind of, this is something to kind of help your perception. I'm going to, 1 times x is x, and then I'm going to put the -3 down here. Remember, the negative can occur to the top or bottom, but I'm putting it on the bottom for the sake of perception. If I rewrite the problem like this, which is the exact same, by the way, this gets you a better idea of stating that, hey, -3 is dividing away from x. How can I get x by itself if there's a -3 that's dividing from it? And that's where you might then be able to say, well, you got to take the inverse, Mr. Robinson. You got to take the inverse of this guy. The inverse of division is multiplication. So I'm going to multiply both sides by -3 right here. And on the left side, the -3's will cancel. All that's left is x. And then here we will get x equals 20 times -3 is -60. You don't need that step right there to do that unless it helps you realize that a -3 is being divided away from an x, and that gets x by itself. That is one approach. You could multiply by -3 from the beginning. Remember, you could, as long as you know what you're doing with it. Another approach, which is a little bit different, you still do the same thing in the end, but it's a different appearance of this thing. I'm going to rewrite that -1/3 x one more time. Remember, it is multiplying, okay? And as it multiplies, in order to get an x by itself, you take the thing that's multiplying in front and you divide both sides by that thing. What if I divide by -1/3 here and divide by -1/3 here? Well, that's good and great. Negative 1/3 divided by negative 1/3 is 1, but then you look at 20 divided by negative 1/3, and this question becomes, how do you divide by a fraction? And the answer is, you don't want to treat it as division. You reciprocate it, you flip the 1 and the 3 here. Okay, you flip the 1 and the 3 and you multiply. We're going to multiply by this guy's reciprocal. So instead of saying divide by negative 1/3, we say multiply by its reciprocal. Instead of 20 divided by negative 1/3, I'm going to do 20 times negative 3 over 1. So I flip the top and bottom, and that's the same thing as dividing by negative 1/3, multiplying by negative 3 over 1. And of course, I'm supposed to do it on this side here. That's of course what gets me my cancellation. Negative 3 over negative 3 is 1. 1 over 1 is 1. I'm left with x here, and 20 times negative 3 once again is negative 60. So it gets me to the same answer because I'm doing the same thing in the end. Let me put this in green. I'm doing the same thing in the end. I'm multiplying both sides by negative 3. But math is a perceptual kind of thing where sometimes people's struggles aren't that they don't know what to do. They just don't know how it looks, how to approach it based on what it looks like. If we change its perception, you're fine there. And of course, I could have just started by multiplying both sides by negative 3 to begin with if you knew what was going on there, and I'd get the same result. So they still cancel in that sort of way there. No matter what you do, you get x equals negative 60. You can, of course, double check that by substituting negative 60 back in, and it should work out. You can see how I said that I'd be teaching this a little more, more of the teaching, showing different ways how to do it, what might be wrong. We'll see if we run into some of those. Okay, number 2. This is one of those dealios that we call a two-step equation. A two-step equation because it takes 2 steps to solve for x. There's a coefficient multiplied in front of x, and there's a constant that's added with the x term. And there's a constant on the other side, some numeric constant without an x with it. So we're going to take 2 steps here. Some number times negative 4 minus 11 equals 13. Well, the last thing we did was we subtracted 11. What number minus 11 gives you 13? Well, you add 11 to figure that out. So what I'm going to do on both sides, it's the both sides thing. If we subtract 11 here, let's go ahead and add 11 to both sides to figure out what that number was. Negative 11 plus 11 is 0. They cancel, and you're left with just a negative 4x on the left side of the equation, which is good. We're getting it more isolated. And a 24 on the right side. That's the number minus 11 that gives you 13. It's 24. Okay, and some number times negative 4 gives you 24. What is that number? Well, it's divided by negative 4 to figure it out. 24 divided by negative 4 is negative 6. And negative 4 divided by negative 4 is 1x, so we get a positive 1x right here, or just x, and a negative 6 on this side right here. And that is the answer for number 2. You can double check that as needed. I can't think of other ways that I'd want to talk about that problem. Of course, you could always do some guess and check measure, but that's not the end ordeal. We're going to be running in some fractions with this, guys, and it's going to be a little bit tougher to say, oh, just, guess and check. It doesn't always work that way. And you might get some fraction answers, too, not just fraction setups. Speaking of fractions, what is the solution of 12 times the quantity 1/2 x plus 4 equals 18? They're saying get x by itself again. They're asking you to do that. I have 2 options to go here, and I'm not going to do the other option I was thinking of. I was saying, hey, 12 is multiplying by this. Let's divide everything by 12. The reason I don't want to do it is because I don't want to do 18 divided by 12. If this number was 2, I'd happily divide both sides by 2, and I'd get 18 over 2. The other reason I don't want to do it is because if I do multiply 12 into this quantity, which, by the way, is a distribution step, I'll talk about that, then I get to do 12 times 1/2. 12 times 1/2 is actually an integer. I won't be left with a fraction anymore if I distribute. So I'm going to prefer to do that. This is more than a 2-step equation because it requires simplification of one of the expressions on the left side through what's called distribution. The distributive property says that if there's a number that if there's something that multiplies on the outside of a quantity of multiple terms being added or subtracted, you can multiply by each of those individual terms separately by the item on the outside. This 12 is going to multiply by 1/2 x, and this 12 is going to multiply by 4. That's what the distributive property is saying right there. Another way of putting it, a times the quantity b plus c equals a times b plus a times c. And maybe we're going to run in some negative things to distribute along the way as well. It can get a little tricky. It can get a little tricky. Okay, what's 12 times 1/2 x? Ignore the x for a moment. That's going to stay there. This is 12 times 1/2 times x. What's 12 times 1/2? 12 times 1/2 is half of 12. 12 divided by 2 is 6. So we're going to get 6x right here, and 12 times 4 is 48. So I got 6x plus 48 on the left side. I got to keep writing this right side equals 18. I got so focused on distributive property, I forgot what I was trying to do. This still equals 18. I'm leaving the right side alone right now. Simplify each side until you get down to what you want to do. Now it's kind of a two-step equation, because now we just got to take those 2 steps to get x by itself. 48 is being added, so hey, why don't we go ahead and subtract 48 from both sides right here, and that will allow us to get 6x by its lonesome. So I have 6x equals 18 minus 48 is negative 30. You can have a calculator on you, I'm sure. Maybe, depends on the teacher. And if we divide both sides here by 6, as 6 multiplied with x, we're going to get x equals negative 5. X equals negative 5. I'll talk about double checking with one problem eventually down the line. I don't personally want to double check right now involving a fraction, especially with an odd number and taking half of an odd number. Let's leave that for later. But you can double check your solutions by substituting them back into the original equation to make sure that the left side equals the right side. Don't stop short of checking to see that if you do have the time and the luxury of being able to do so with a better problem than this one. All right, number 4. Find the solution. Oh yeah, inequalities. We're going to run into these. Find the solution for negative 7.5x plus 2.5 equals negative 12.5 and graph the solution on the number line. Let me rewrite this one more time so the words aren't all around it, and maybe I can do some more work with this guy. There are 2 ways you can do this problem. It depends on whether or not you feel comfortable dealing with decimals. And again, if you have a calculator, it might help you more. That doesn't mean a solution will have a decimal on it. In fact, I don't think this one does. So let's do this one way, the kind of typical way right here. We're going to go ahead and deal with this as it is in this decimal form. So I'm going to get x by itself. Let's move this term over that's being added to this term here. Minus 2.5 on both sides, minus 2.5. And you can see right now that this decimal is going to be taken care of right here. Negative 12.5 minus 2.5 is the opposite of 12.5 plus 2.5. Let me kind of change that. Well, think about this like money. $12.50 plus another $2.50. That's $15. And I am also going to, but it's the opposite of, so negative 15, right? Negative 15.0. I'll leave it as negative 15. All right, I'm going to divide both sides here by negative 7.5, and you might say, uh-oh, that's a problem. Good thing is 7.5 is half of 15. That means if I divide these by 7.5, I should be getting 2. Now, a negative divided by a negative is a positive, so I'm going to make sure that I'm going to put 2 on this side right here, and all that remains on this side is x. Okay. Now, is this equals? No, because we have an inequality going down here, so we got to put an inequality. Is it less than? It's a good question. Dividing by a negative kind of changes things here, guys. When you divide by a negative or multiply by a negative in an inequality, and I don't think I'm going to get too deep into this one. I know I've done it in older videos last year. But if you divide or multiply by a negative number in an inequality, what happens is the inequality flips. It actually turns over to the other side. I want to get into it, but guys, I'm not going to. The main reason is because something that was largely positive now becomes largely negative. Okay, so it becomes what was greater than here now becomes less than. Large negative numbers are smaller than small negative numbers, right? Would you rather owe somebody $2 or $100? I'd rather owe them $2, I guess. So anyway, what happens is this inequality flips. Like I said, I'm not going to get deep into it. There are a lot of ways I could get deep into it. I hinted at it. But we're going to flip this guy right here, and it becomes a greater than at this point. X is greater than 2. X is greater than 2. And that is the solution for this guy. I was going to talk about another way we could do this problem by ignoring decimals outright if we do a decimal shift. I think for the sake of time, we'll just... These came out cleanly enough, and they're just halves. I think this one's fine. If another problem gets a little more complicated, then maybe I'll deal with it then. All right, x is greater than 2 is my solution set to this thing. That's not just one number. What are numbers greater than 2? Well, 3, 4, 5, 6, 1,000. Pi, 3.14, is more than 2. any number. So that's why we like to graph these ones on a number line. And on a number line, I'm going to go ahead and like do 0, 1, 2, 3, 4, 5, etc. These are numbers on my number line, yodelehihu, and we are going to graph this guy. What I say are numbers that are greater than 2. 3 is greater than 2. 4 is, 5 is, 6 is, 7 is, 3.14 is, pi. What about 2.5? That's greater than 2 as well. All these numbers to the right of 2 are greater than 2. So instead of drawing a bunch of points in an infinite set, we just draw a nice thick old line here, maybe in green in a different color, and we draw a nice arrow here, just like the number line arrow, to say that all my x terms can go this way. Now, how far can it go? To the left. As close as 2, but 2 doesn't count. Is 2 greater than 2? No. So how do we indicate that? We can't put a closed circle like this because that would mean that 2 counts. So they have a format that is an open circle. Instead we say, what if I put kind of a nice fat open circle right here and says 2 don't count, but 2.0001 will count because that number is greater than 2. And that's the format that they use. That's the notation, open circle. And if I have a variable greater than my boundary point right here, I'm going to graph to the right of it. Greater than goes to the right, less than goes to the left. Yes, even with negatives. Now the inequality flip, to keep that in mind. And that is your final solution set. That's the graph. Any of the numbers greater than 2 work. You can plug it in and check and try numbers that way. All right, number 5, solve 3 times the quantity t minus 1 equals 18 minus t. What is the solution? What is the solution? Notice you have the t variable, that's what we're solving for this time. You have it on both sides of the equation, and one's inside a quantity here. What I mentioned on, I think, number 3 was when I distributed here, you know, let's simplify both sides of this equation first. Let's make sure that everything is taken care of on opposite sides of the equal sign, and then we can start moving pieces over. Because it looks like I got to get my variables all on one side of this, the equation alone. All right, 3 times t is 3t. 3 times negative 1 is negative 3. That's my distribution step right there. And here I have 18 minus t. 18 minus t. If you're handwriting t's, guys, try and curve it or something. That way it doesn't look like pluses. You don't want like plus t and you're saying, why did I put plus plus? What's going on here? All right, let's get t by itself on its own side of the equation. That will help us solve for t. So I'm going to start, I prefer having my variables on this side, and I prefer having them positive. Let's kill 2 birds with 1 stone right here. Let's go ahead and add t to both sides of the equation right here. And keep in mind, t also means 1t. I'm going to add this 1t over, and it's gone on the right side. All that's left is 18. I'm losing my voice, guys. I was teaching all day, and I had phone conversations, and I have back to school night later today. Sorry about that. I might lose my voice here. 3t plus 1t here, remember it is 1t, is 4t, and I still have the minus 3. It depends on, some people do these in one step. Like, I personally do this all mentally. I don't write all this unless it's for you guys. But some people do it in one step. They're like plus 3, all that. Let's just save it for the next step for now. I'm going to do plus 3 to both sides to move this over, the constant terms, over to the other side so that t is all by itself here. And I have 4t, well, 4t is by itself. So I'm going to have 4t equals 21. And I will now divide both sides by 4. I'm going to guess I didn't make a mistake, but you can't do 21 divided by 4 and get an integer value. So I'm going to just go ahead and divide by 4, and I'll take what I can get here. This is t equals 21 divided by 4. Now that is an exact answer as an improper fraction. I'll give you other versions of this, such as the decimal equivalent and mixed number equivalent. Now, we do not generally use mixed numbers once you hit algebra and onward. It occurs, and sometimes you have to actually convert from mixed number form to improper fraction form, because improper fractions are easier to compute with, even if they're not easier to perceive what actual number it is. If I asked you, what 2 integers are 21 over 4 between? 3 and 4, 7 and 8? Some people won't know right off the bat, so sometimes having the mixed number helps them, or the decimal equivalent, even if it's an approximation. So that's why sometimes people like it and use it. So let me show you both of those and what they would be. Let's start with the mixed number first, because I actually think we're going to convert mixed numbers to improper fractions in this video. So converting to a mixed number here, 21 over 4, What you do is you literally divide 21 by 4, you see what the whole number component of it is, and you see what remains. 4 goes into 21 as many as 5 whole times, because 20 divided by 4 is 5. It can't reach 6 times unless you have up to a number that's 24 or larger. So 21 over 4, it's kind of like if you have pizzas, whole pizzas cut up into 4 slices each, you can fill up 5 whole pizza boxes. And then how many slices remain? Well, 20 divided by 4 is 5, so there's 1 slice left over here. This is 5 1/4. This is 5 1/4 right here. That's what t also equals, 5 1/4. As a decimal, 1/4 is 0.25, like 25 cents. So you can also rewrite it as 5.25. These are all t equals variations here, and I'm just kind of giving you different versions. This is the preferred answer, I'll tell you what. And as long as you can reduce the improper fraction, there's nothing to reduce here, but if you can reduce it, do that. But this is the preferred answer, guys. I'm just giving you other components, and we're going to convert from mixed number to improper fraction pretty soon. I don't know exactly when, but I know I've seen them. All right, that's the solution to that. It was a fraction answer. Some people take this and they say, it's not an integer answer, so no solution. That's not what no solution means. No solution means you can't plug in anything for t that'll work. There's no integer solution, but there is a solution, and that's it. Okay, number 6, we have a word problem. Write and solve an equation for the following situation. In 1 week, John traveled 5 times the difference of the number of hours Bob traveled and 3. Kind of a weird sentence. We'll use some numbers to kind of help you out here. Together, they traveled 21 hours. Find the number of hours each person traveled. All right, whenever you're doing a word problem, whether or not you're writing expressions or solving equations, whether you're doing one or the other, it's always best that because you're going to be using variables, and they didn't give us any. So let's use variables for these 2 people and how much they travel. And let's define those variables so you know what units you're using and you know how these things are being used. So the question here says find the number of hours each person traveled here. So when we solve for our variables, our answers are going to be in hours. So John traveled a certain amount of hours, and Bob traveled a certain amount of hours. Why don't we go ahead and define variables using the first letter, their first initials, because they're different. J will be, some people just do something like this, J equals John. There's a problem with just writing J equals John. If I get J equals 12, what does that mean? Does that mean that John is 12 years old? Does that mean that John is 12 feet tall? Does that mean that John finished 12 homework problems? No, it means that John traveled 12 hours. So we need to indicate that. You can't just say J equals John. That doesn't help anything. We're going to go ahead and let J equal the number of hours John has traveled. So this is a key thing that you want to do for yourself. And if they ever ask you to, then you got to do it. Now, or you could put time John has traveled, and you can say it's in hours. This is my unit here. Whatever, if J equals 12, it's going to be John has traveled 12 hours. And I'm going to let B equal the number of hours Bob traveled. I'm just going to go ahead and do it that way. Oh, I don't need that. I'll put quotation marks to be consistent. Number of hours Bob traveled. Boom. Define variables. That's going to help us. How does this help us? They give us 2 different sets of information, and we're going to write equations based on it. Does 1 week have to do with the information here? Not really. They don't talk about the week at any other point. They could just say that they're just saying that's how they recorded it. I'm going to ignore the 1 week part. John traveled 5 times the difference of the number of hours Bob traveled in 3. Okay, that's a lot of stuff. I'm going to save that one for a moment. Let's look at the next one. Together they traveled 21 hours. Okay. I want to write an equation based on them together traveling 21 hours. Now, J and B happen to represent the number of hours they each traveled. If you have trouble writing out an equation with this right now using this information, here's where I recommend this groovy, kind of faux way of approaching this, and just say, make up numbers for a moment, think about what you do with those numbers, and then supplant those numbers with your variables. Like this. John traveled 5 hours, Bob traveled 3 hours. How many hours did they travel? Then you would say 5 plus 3 equals 8, right? I don't care about that answer. I made up those numbers. I care about what you did to get it. You did 5 plus 3. You took the number of hours John traveled, the number of hours Bob traveled, and you added them together. Why is that important? Because I have variables that express exactly that. Let's take the number of hours John traveled plus the number of hours Bob traveled, and together that'll total how many hours they traveled together. We actually know that information. It's 21. So that is an equation that we could write to solve this thing. Now, that's one equation. This isn't the only equation we can use, j plus b equals 21. And if I say solve for b and j, you can't just do that because there are a lot of solutions here. John could have traveled for 1 hour, Bob for 20. John for 10, Bob for 11. There are a lot of answers. So we use this other bit of information that they have up here. I'm trying to find a different color I haven't used. Let me just ignore this screen. John traveled 5 times. This one's going to be weird. John traveled 5 times the difference of the number of hours Bob traveled and 3. So this really gets weird when they say that Bob traveled and 3. You're like, what the heck does that mean? You got to clump this up in different parts here when you're solving, when you're writing this equation. And I'm going to use real numbers to help you out again for this one part, see if it makes sense in a bit. But right here, they're talking about, just right here, the difference of the number of hours Bob traveled and 3. They're talking about the difference between Bob's hours and 3 hours. What's the difference between those two? Let's say Bob traveled 5 hours. What's the difference between 5 hours and 3 hours? Well, it's 2 hours. How do you get it? You do 5 minus 3. However many hours Bob traveled, B, however many hours Bob traveled B, let's take its difference. John traveled 5 times this distance here. This difference right here. Distance is difference. B minus 3, let's get 5 times that amount. What's 5 times the amount of the difference between 5 and 3? You do 5 minus 3, which is 2, and then you multiply it by 5. Okay? Yeah, that's 10. That doesn't matter. How do I write 5 times right here? Do I just write this? 5 times the difference of Bob and 3. No, because the problem is here I don't get to do b minus 3 first. I want to subtract b and 3 first and then multiply by 5. I can write 5 in front, this is fine, but I got to put parentheses around this. I got to quantify the b minus 3, make sure that this occurs first, and then I multiply it by 5. Whatever number this is, that's how many hours John traveled. So what do I do here? This equals j. This equals j. J equals 5 times the quantity, b minus 3. That's an equation represented in terms of Bob for John. How many hours did Bob travel? 5? Oh, 5 minus 3 is 2. 2 times 5 is 10. John traveled 10 hours if Bob traveled 5 hours. Now, that's not the answer because 10 plus 5 is not 21. And we're not going to guess and check. We're going to solve this. So how do we solve it now, guys? We have what's called a system of equations. We have 2 equations right here, top and bottom. All right, 2 equations. And we are going to use something called substitution method in order to solve for this thing. Because the problem is each equation has 2 variables. And I already mentioned that up top. There's an infinite number of solutions here for John and Bob. I don't know which one's correct. We got to find the j and b that works for both equations at the same time. So what we're going to do here is this. J happens to equal this thing right here. This is the same thing as j. This might as well be j. This might as well be j. What I mean by that is let's take this information and let's substitute it in for the j that's up here. This can take j's place. It might as well be j because j equals it. I know I'm saying the same thing a lot, but I'm trying to rehash that over and over. This is j. This is j. All right, Mr. Robinson, you're saying that. Why do you keep saying that? Why is that important? Because it's going to take j's place. Why are we taking j's place, Mr. Robinson? Because now we have an equation that only has b's in it, and we can now solve this. This is my new equation written as a result of substituting 5 times the quantity b minus 3 for j in the top equation. And now I have something that I can solve for b with. So I'm going to do this part a little faster. I realize this video is going longer than anyone would have wanted to anticipate. It's a half-hour video, and we're not even a third of the way done with everything. However, hopefully, after we've done problems like this, guys, then it should go a lot faster for the future problems, if you know what I mean. Again, I'm doing this for those who don't understand this yet. Hopefully you're understanding it now that I'm slowing it down. 5 times b, 5 times negative 3. We're going to get 5b minus 15. And don't be one of those people. I sometimes have students who will go like, is that a 5 or an S? Fool, where did an S come in this equation at any one point? There's no S's here. I have J and B. I never had an S. That's a 5. Sorry that I can't write 5s the same way all the time. All right, this simplification. This is the first time we're going to see something like this on one side of the equation. These two terms got to combine right here. 5b and b, positive b. Don't do 5b minus b. This minus has nothing to do with that 5b or that b right there. 5b plus 1b is 6b. I will combine like terms right there, and then I have the minus 15 still on this side, kind of more looking like a 5 there. If I add 15 on both sides here, and I'm kind of running out of room because of my face. Let me hide myself or make myself smaller here. If I add 15 on both sides right here, okay, I'm going to get 6b on the left that remains and 36 on the right, which remains. Now I'm going to divide by 6. I'm kind of running out of room, guys, so I'm going to divide both sides by 6 here. 36 divided by 6 is 6. So b equals 6. Now don't stop your thing right there. Make sure that you answer the question being asked. All the previous questions said solve for your variable. This time it says find the number of hours each person traveled. All right, so this one's a little different question. I got b equals 6. That helps me find out how many hours Bob traveled, though I still haven't stated it yet. And I don't know how many hours John has traveled yet. So how do we find out how many hours John has traveled now that we find out Bob has traveled 6 hours? You can use either bits of information here to solve. I have 2 separate equations. Either one is good for you to solve for different reasons here. I can substitute 6 for b in the top equation, and I'll do both, or the bottom equation. If I substitute it in the top equation, it's kind of nice because the numbers are a little smaller. And, I just got to do j plus 6 equals 21 and just subtract 6. So I get j equals 15. In other cases, this isn't the preferred way to solve it because here, this already says j equals. That means that you don't have to isolate j. It's already on its own. So I could just say j equals 5 times the quantity 6 minus 3. Do this with me in your head here. 6 minus 3 is 3. 5 times 3 is 15. So here once more, j equals 15. So no matter what you do, you get j equals 15, whether you use the top or bottom equation. But we need to use both of those equations in order to solve this guy. An expression for John in terms of Bob for hours driven, and one that says how many hours they travel total. I'm still technically not done because there's no more math, but because I need to answer the question, find the number of hours each person traveled. I'm going to go ahead and I'm going to type, but I'm going to get this thing written out for here. All right. So here we go. It's going to be this. Hang on. I just screwed something up. John traveled 15 hours, and Bob traveled 6 hours. Right? That's the final answer right there. Right there. Right there. Okay. There we go. I'll tell you what, it was the most work we've had of all our problems, but it wasn't a lot of work. I spent a long time on it, but if we have another word problem, let's go more rapid pace, shall we? For your sake, for my sake, for everyone's sake. Not a long problem, just more work than all the other ones. All right, 7 and 8, simplify. 7 simplify, 8 solve. So you can tell this kind of just goes in a different format from the other questions. I don't know if this was the next question onward, but I'm going to go ahead and distribute right here. This one can get tricky with distribution. You got to be careful. Are we solving for x or y? No, we're not solving for anything. They just say simplify in this case means get everything out of parentheses, combine like terms. Get everything out of parentheses, combine like terms. When I distribute, I'm not just distributing a 5, folks. I'm distributing a negative 5. A negative 5 is going to multiply by y. A negative 5 is going to multiply by 4x. So on one stage of this, I could say 2x minus 5 times y minus 5 times 4x. So you can kind of just get the gist right there. That's what's happening in the distribution step. Now that becomes, not equals. Now that becomes 2x minus 5y minus 20x. You don't need the in-between step, but there it is. Okay, 2x minus 20x can combine. 2 minus 20 is negative 18, so I'm going to have negative 18x minus 5y, and that is the simplified version of this guy. That's it. I'll leave it at that. Nothing to solve there. There's no equal sign, no inequality symbol. This one on number 8 has an inequality symbol, so let's go ahead and attack that one. Let's solve this guy right here. They don't ask you to graph. I kind of wish they did. I want to graph this for a very particular reason where I want you to be careful on graphs on these things. This one is a tricky problem when it comes to graphing, not solving, but graphing. All right, I'm going to do this problem in 2 ways. First way will be in purple. This first way here, I am going to leave the x I'm going to leave the x on the right side for this first step. This first way. Add 25 to both sides. Okay. And then we get 3x equals 21. Not equals. I have 21 on this side. I have the less than symbol. 21 is less than 3x. There we go. And then I divide both sides by 3. I was going to say 7. 7's the answer. And then x is on the right side. 7 is on the left side. It says 7 is less than x. Okay, there's the answer. Now, if you were asked to graph this on a number line, let's say 0 was here, let's say 7's right here. On a number line, less than, not less than or equal to means you'll have an open circle here. Here's where things get tricky. Everyone who reads this thing will often read this as less than. I would almost even agree. This is a less than symbol. But less than, this is read as less than if you're reading this left to right. This says 7 is less than x. Well, if 7 is less than x, then that means x is greater than 7. Right? If 7 is less than 10, 10 is greater than 7. So the problem with this is we are comparing number to variable right now. We're saying 7 is less than all my numbers that x can be. But if people see less than, they think less than means we go left. The problem with that, of course, is these numbers, including 0, are not more than 7, right? 7 is not less than 0. 7 isn't less than 0. This is the wrong direction that we're graphing this, and it's because you see this as a less than. The real problem isn't that you see this as a less than. The problem is that we're reading this with the variable on the right side. So if you ever run into this, I highly recommend, W-H-O-L-L-Y, I wholly recommend and highly recommend that you flip this over. Everything, x on this side, greater than 7, and you now know to graph to the right. Okay, that's one way you can approach a problem where your variable is on the right side, right there. Here's the other way you can approach the problem, which I'll do in dark blue, is if you want to move the x to the left side to begin with. Now, in moving it, let me hide that. Let me put my phone on vibrate. Now, in moving this thing, I got to subtract 3x to both sides. And I'm also going to move the 4, that negative 4 over at the same time. So I'm going to do minus 3x to both sides, guys, right here. And I'm going to go ahead and add 4 to both sides right now immediately. Hopefully that's not too cluttered for you. 3x minus 3x is 0. Negative 4 plus 4 is 0. Those go away. And now I have, give me a moment. Now I have negative 3x on the left side is less than negative 21 on the right side. Okay, and now you divide both sides by negative 3, and here's the part where you got to be careful. Once again, we are dividing by a negative. That means the inequality should flip. So instead of writing x is less than positive 7, negative divided by negative is a positive, notice this thing has to flip around. Notice right here it has to flip around. You can tell right there. It says this has to flip around. And I just flipped my phone out of the way because people can't stop texting. I am that popular. So I got to flip this guy around when you divide by the negative. X is greater than 7 one more time. So no matter what you do with this problem, you're kind of stuck with the idea of you can't see that. You got to, yeah, my face is in the way. You got to take something into account right here when it comes to solving this problem. Either putting x on the left side, dividing by the negative and flipping things. Or when you get x on the right side in your solution, you got to flip everything around if you want to read it the proper way when it comes to graphing on a number line. That's why I wanted to graph on the number line here. So you knew what it meant if you have this problem, because I don't know if I'll have that problem again. Okay. All right, that was number 8. Let's go ahead and move on to number 9. I have a mixed number, 5 1/4. Hey, we've seen that number before. 5 1/4 equals y over 4 minus 1. Now, the first thing I'm going to do in this problem is I'm going to convert this to an improper fraction. I don't like the idea of mixed numbers for a lot of different reasons. Mainly just calculating with it is just not fun. when there's overdraft and you get an improper fraction within this bit right here, common denominator, all this stuff. I don't want it. I'm going to convert this into an improper fraction. Now, if you remember, it was 21 over 4. But if you're not that lucky to get a problem that was like something we've seen before, what you do here, let me just write the 5 1/4. What you do is you take the denominator right here, this 4. You're going to multiply it by the whole number here, 5. And then you're going to add this number right here, that 1. 4 times 5 is 20. 5 plus 1 is 21. And you're going to leave that over 4. Now, why do you do that? Let's think about pizzas. Let's say you had 5 whole pizzas that were cut into quarters. This says you have 5 whole pizzas plus another quarter of a pizza. Maybe there's another slice left over. The 21 represents how many slices you have total. If I have 5 whole pizzas cut into quarters, how many pizzas are in those 5 whole boxes? 4 times 5. 4 times 5. And then you have another whole quarter of a pizza. Sorry, you have another quarter of a whole pizza left over. That's one more slice plus another one. Goes right there. So there it is. Okay, so here we go. Equals y over 4 minus 1. Again, multiple ways you can do this problem. I'm only going to go one way this time, and I'll say the way that's going to be easier for me is I do not like fractions. You do not like fractions. We all do not like fractions. So, guys, I got to do this 2 ways because I got to talk about common denominator. Let's do the way that we hate, fractions. We hate fractions, and yet we're going to deal with it in terms of fractions. I got to get y by itself. Okay, this negative 1, I got to add over here, plus 1. I got to do 21 fourths plus 1, guys. I got to do 21 fourths plus 1. Well, plus 1, I got to get this into a common denominator with this 4. See, 1 is 1 over 1. You can't add straight across like you multiply straight across with these things. You got to turn this somehow into a 4. And you turn it into a 4 by multiplying top and bottom by 4. 4 over 4 right here. And I'll multiply straight across right here when I go ahead and do that math. And I still have y over 4 on the right side, just like that. Okay. So in rewriting all this, I have 21 fourths plus 4 fourths equals y over 4. Okay. These all have fourths in here, and there is a way to clean that up. I'm not going to get into right now. Just let's play with the common denominator. 21 plus 4 is 25. You add the top, you keep the bottom. 25 fourths equals y over 4. Y is divided by 4. I got to multiply both sides by 4 to get y by itself. And the cool thing about this that I was kind of alluding to in that previous step here is that the 4's get to cancel right here. 4 over 4 is gone. 4 over 4 is gone. If something over 4 equals 25 over 4, guys, then that something is 25. You know what I mean? That something is going to be 25. There's no way to not make it that. So we're going to get y equals 25 right there. Okay, that's one way to do it. That's actually the non-preferred way. However, I want to make sure you have an idea of common denominator. So the way I did that once again is I kept the fractions in, I added 1 to both sides, and I went on my merry way. The alternative to this is to get rid of the fractions from the onset, because who likes fractions, right? So the alternative to this guy right here is I get rid of the fractions immediately. And you notice how I multiplied by 4 to get rid of the fraction under the y, and it got rid of the fraction under the 25. We can do the same thing right now immediately and get rid of those fractions as well. You just got to be careful on how you do this because you got to make sure that it's used everywhere. So if I decide to multiply both sides by 4, that's fine. The thing is, though, the 4's got to multiply by every term on this right side, by both terms on this side here. Okay. So what does that look like? We're going to have 4 times y over 4 and 4 times negative 1, whereas this 4 obviously multiplies by 21 over 4. Well, we just saw what happens when we multiply 4, by something that divides by 4. The 4's cancel. So right here, 4 over 4 is gone. All that you're left with on that part is 21. And then on the right side, gets a little interesting. Yeah, 4 times y over 4 cancels the 4's out, so you're just left with y. However, make sure you do not cancel this 4 outright so that you don't use it for the negative 1. 4 gets to multiply into both of these, not just y over 4. I don't want to cancel it outright. 4 still multiplies with negative 1, and I still have a negative 4 left over. This is y minus 4 right there. 21 equals y minus 4. Okay. So I'm just going to go ahead and add 4 to both sides, and we're going to get y equals 25. We'll get the same answer there as well. all is merrysome. Y equals 25. Just going to write it on that side like that. All right, get the same answer no matter what. That was, to me, faster, and it gets me into whole numbers right there. The problem set is making sure you multiply both sides by 4, and you know that when you cancel it, it doesn't go away here. You still use it. All right, number 10. This time I will not graph it. Solve 7 times the quantity x plus 5 is less than 42. This is the one problem I'll probably get to do quickly with you guys. Distribute the 7 into both parts right here. We get 7x plus 35. Multiply the 7 to both is less than 42. Subtract 35 from both sides right here, and we will get 7x on the left side, and on the right side, 42 minus 35 happens to equal 7. So 7x is less than 7. Divide both sides by 7 now, and 7 divided by 7. See, whereas right here they cancel, I don't want to just cancel them right here. They don't go away. They go away here because 7 over 7 is 1, and 1 times x can also be written as x. That's why we cancel, and that's our goal. However, here, 7 over 7, like I said, is 1. X is less than 1. That is your solution set there for number 10. Hey, fastest problem I got to do because I finally got a problem that was simple and we've covered, and I didn't have to graph. And I didn't have to warn you about parts too much except for don't cancel right there. All right. Numbers 11 and 12. So you can see, once again, number 11, this is going to be kind of more straightforward. The one thing is that negative in front you got to really adhere to. This negative 5, guys, is going to distribute into the 2, and the negative 5 is going to distribute into the y. Remember, a negative means it will apply to both. Negative 10 is negative 5 times 2. Negative 5 times y is negative 5y, and that equals 55 right here. I'm going to move this negative 10 over to the other side to combine with the constants by adding 10 to both sides right here. Sounds glorious. Because it was negative, I will be adding it. And there you go. Now I have negative 5y equals 65. And now I get to divide both sides by negative 5. By negative 5 here. And the negative 5's cancel. And I get y equals negative, what's that, 13? Negative 13. Hey, we divided by a negative. Do we flip the equal sign? Yeah, we flip it and it still remains an equal sign. There's nothing you can do to that. You know, something my students have actually brought up to me and asked me questions with before is, notice how I added 10 right here and right here. Some people ask, why don't we add 10 right here? Why doesn't 10 get added right here? Because, well, for one thing, we got to keep balance in the equation. So if this becomes 10 more on this side, we should only get 10 more on this side. But then people ask, but what about, remember this multiplication? I multiplied by 4 on both sides, and I multiplied 4 with every term right here. Why did I do that here, not here? 4 is multiplying by the quantity, guys. Remember, the quantity happens first in order of operations. We compute what's there, and then we multiply that whole set by 4. This whole set is technically being added by 10 just once. I'm just combining the ones that make it go away. So that's just the goal right there. We only add it once to both sides. Like, we only multiply 4 once to both sides. But 4 is multiplying by the whole quantity, so each thing gets affected 4 times larger. Multiplication is on a different set than addition when it comes to terms. So there it is. All right, number 12. What are the terms in the expression negative 3x minus 15y plus 18z minus 23? Terms are the items in an expression. An expression is this mathematical statement right here. All these things make up an expression, make up the mathematical expression. Okay, that's the expression. The terms are every bit in an expression, every item that's separated by addition or subtraction. So your 4 expressions, there are 4 terms in this expression: negative 3x, negative 15y, 18z, and negative 23. The sign in front of it matters. So your 4 terms are negative 3x, negative 15y, positive 18z, and negative 23. There they are. Not much I can say about that, guys. Just those are your 4 terms. Let's move on. Number 13. What are the coefficients in the expression? Same expression. What are the coefficients? Coefficients are the numbers or constants, whatever you call them, that are multiplying by your variable or variables in each term. So in the term negative 3x, your coefficient is negative 3. That's the number that multiplies with the x. For the term negative 15y, your coefficient is the negative 15. It's the thing that's not the variable, if you will. In 18z, your coefficient is 18. And in negative 23, your coefficient There is no coefficient. Sorry, I should stop there. This negative 23 is called a constant. This one's called a constant, not a coefficient. It's not multiplying by a variable. A coefficient is another way of saying scalar. You might not know what that means. Your variable is being magnified or shrunk or something by, x is becoming 3 times larger in essence. The coefficient is saying that everything is 3 times larger than it was. Negative 3 times larger, but you know what I mean. What else did I want to bring up? Oh, what if I had something like this? Negative x over 3. Just like that first problem. Negative x over 3. What's multiplying? See, this answer is not negative 3. What's multiplying in front of x? This helps me go all the way back to number 1. Remember negative x over 3? Here's negative x over 3 right here. What was it? Negative 1/3 x. What's multiplying in front of x there? It's a negative 1/3. This guy's coefficient is negative 1/3. All right. So that's how coefficients work there. I know that's an extra problem, but there you go. All right. Number 14, a word problem, but we've done one before, so hopefully this will go a lot faster. Henry is saving money to buy a new pair of glasses that cost $225. He has $45 saved, and each week he adds $30 to his savings. How long will it take him to save enough for the sunglasses? All right, it's a different kind of word problem, so maybe slow it down just a little bit. All right, what are we trying to find out, right? We want to define a variable based on the thing we don't know. How long it will take him to save enough for sunglasses. So you can use any variable you want. I'm just going to use h for Henry, but again, h doesn't equal Henry. H equals number of, what is this? Every week, each week. So number of weeks, I should probably put W, huh? Let's do W. Let's let W equal number of weeks Henry saves money. Now the unit for this thing is in weeks. When we solve, if W equals 10, it's going to be 10 weeks, right? I don't know what the answer is. All right, well now I do, now that I'm looking at the problem. Henry's saving money to buy a new pair of glasses that cost $225. Now this is the only variable that we need. There's no other variable that we need in this. It's not going to be a system of equations. It's going to be one single equation. He has $45 saved, and each week he adds $30 to his savings. So let's first look at this as a table, guys. As a table here, if we're talking about W as the number of weeks here, and dollars as far as how much money he has $45 saved. So at week 0, he has saved $45. That's how much you start with. After 1 week, he adds $30 to his savings. That's $75. This is one way you could answer this, by the way. You could answer it this way. After $2, he saved $105. Did I say 2 days? 2 weeks. After 3 weeks, he saved $135. 4 weeks, $165. 5 weeks, $195. And 6 weeks, $225. So it'll take Henry 6 weeks. 6 weeks to save up to $225 in total to buy a new pair of glasses. Pretty expensive glasses there, but there you go. Now, that's one way to do it with the table. I'm going to use the table to make sense of how we can make an equation out of this. Notice that weeks do influence the $30 savings bits. Even when there were 0 weeks, he still had $45 saved. So if we were going to try and write an equation to say, I'm going to write an equation that has to do with a left expression and right expression here. The left expression is going to be how much money Henry has saved. This is after W weeks. After W weeks. How much money has Henry saved? We're going to do an expression that has to do with that stuff. This side of the equation is going to be how much money Henry needs. Now, how much money does Henry need? Henry needs $225. We want how much money Henry has saved after W weeks to equal how much money Henry needs, right? If you need $225 and you've only saved $105, that's not equal, that's not good enough. So right here, we're going to use an expression here. Now the 45 happens regardless of whether he saves a dime after the fact. He already has $45 saved. So I'm going to add 45 to how much he's going to save week after week. Now to get this next part, so I'm adding 45 to it. So How does the other part work? Well, how much money does Henry save? Just ignore the 45, just $30 per week. You save $30 per week. How much money have you saved after 2 weeks? You do 30 times 2. How much does he save after 10 weeks? You do 30 times 10, right? So how much does he save after W weeks? You do 30 times W. You take $30 per week times the number of weeks Henry's saving money, and this is going to give you how much money he's adding to the 45 that he already has. So this is your equation right here that we're going to use to solve for W in terms of doing that. So I'm going to go and erase what's underneath here. You can go back to it if you need it, or pause the video, whatever it is. I'm going to subtract 45 from both sides here, minus 45. And then I'm going to go ahead and, whoopsies. I'm going to go ahead and divide both sides by 30 here. Divide by 30, divide by 30. I feel like I'm saying something like bye-bye birdie. Divide by 30. 180 divided by 30 is actually the same as 18 divided by 3, believe it or not, and that is 6. W equals 6. Now, in solving this, we solved it this way using a table. We solved it this way using the equation, setting it up, building it. There are a lot of problems like this, guys. Like a taxi driver does this, and you work at a job and do. There are a lot of ones where they give you a startup amount, which is your constant term, and then your other one with the coefficient and variable. I'm using the words. The other term that changes over time based on what you're doing. After this many hours, after this many miles, the blah, blah, blah happens, and it's a linear rate. So, but we're not done. We've solved for this thing, but we haven't answered the question. How long will it take him to save enough for the sunglasses? It will take Henry 6 weeks. It will take, I was going to say, oh, Henry. It will take Henry 6 weeks, put the number 6, 6 weeks to save enough money for these sunglasses. Sunglasses is one word, ain't it? Sure is. All right, so there we go. That's your answer. You could probably just say 6 weeks and get away with it. Just make sure you have units. Don't just say W equals 6. The one, you know, you could get away with saying W equals 6, actually, if you define your variable. W equals 6. Great. What does W mean? The number of weeks Henry saves money. 6 weeks Henry saves money. So it kind of works. That's why defining a variable is also kind of nice. I notice I've kept myself small this whole time. I want to get myself a little bigger again. All right, 2/3 of the way through. I sure hope these ones are faster now that we've kind of covered a big bulk of what we're doing here. Bob's sister is 6 years older than twice Bob's age. Oh, God. The sum of their ages is 42. How old is Bob? Okay. I'm going to define variables again. I'm going to say B, let's let B, not just Bob, Bob's age. Bob's age. We're doing this in years. Bob's age is in years. Sister starts with an S. Do you want to use an S? Let's try an S here. Let's let S equal Bob's sister's age. That's a lowercase s. Bob's sister's age. Hopefully there aren't any 5s in here with the S, and if they are, I'll definitely differentiate them. Just like a T and a plus. All right. All right, this information is a little harder to work with than this information right here. I think their sum of their ages is 42 is a lot easier to deal with. So let's start with that. Just like the John, was the other guy named Bob? I think so. Just like the John and Bob scenario, the sum of their ages is 42. Bob's age plus Bob's sister's age equals 42. B plus S, not a 5, equals 42. That's one equation. Again, we need 2 equations for this one because there are so many different ages. Bob could be 30, sister could be 12, things like that. But there's so many more different things. Bob could be 40, sister could be 2. Okay, Bob's sister. Oh, Bob is older than Bob's sister is older than Bob anyway. Bob's sister is 6 years older than twice Bob's age. You know what's hard for people to cope with right here? The twice part. Let me ignore the twice part for a second. Let's see if we can just do this part without the twice. Bob's sister is 6 years older than Bob's age. Could you come up with an equation that way? I think we could. Let's write an equation here that has to do with how old the sister is in terms of Bob's age. Does the sister equal Bob's age? No. But we're going to make an equation that involves sister on one side, Bob on the other side, and say what you have to do with Bob to make it the sister's age. Bob's sister is 6 years older than Bob. Again, I'll put in the twice later. Bob's sister is 6 years older than Bob. What would I have to do to Bob's age to match sister's age? Because a lot of people do this. They do S plus 6. They say, sister, 6 years older than Bob. No, if you add 6 to S to make B, that means S is a smaller number. Sister is not younger than Bob. She's older. We have to add 6 to Bob to match sister here. It should say B plus 6, like this. Bob is younger. You need to add 6 years to Bob's age to match sister's age right there. So that's what that would be. All right, let's deal with this twice portion here, now that we have that part in. 6 years older than twice Bob's age. That's saying if you double Bob's age, then the sister's 6 years older than that number. Okay, then the sister's 6 years older than that number. So if we double Bob's age, we don't double the sum of Bob's age and 6 years. We don't put parentheses. We just double Bob's age there. So that's our system of equations for this guy right here, folks. And we're going to solve this the same way that we solved the last one, using substitution. If S equals 2B plus 6, then 2B plus 6 can take S's place in the other equation. This allows us to solve for B. Because now we have the substitution thing right here, we can say B, here's this equation, B plus, here's S, 2B plus 6, right? That guy's S right there. B plus 2B plus 6 equals 42. Now, I didn't need parentheses, and this isn't a distribution because there's a plus here. I just put parentheses to indicate that whole grouping represents S, okay? So let me get rid of the parentheses now. I guess they're not needed. So B plus 2B, 1B plus 2B is 3B. I'll go ahead and combine those two. 3B plus 6 equals 42. Let's see if you guys are advanced enough for me to just say subtract 6 on both sides without actually writing minus 6. If I subtract 6 on both sides, 6 goes away on the left. All that's left is 3B. If I subtract 6 from this side, I get 36. So right here, 36. Now I divide both sides by 3. On this side, I'll be left with B, and 36 divided by 3 is 12. So B equals 12. Bob's age. Bob is 12 years old. Okay. And this is one of those scenarios, again, where you can substitute 12 back into either of these top two equations right here, and then you can solve for S. I'll go ahead and do it in both so you can just see it along. If I do 12 right here, 12 plus S equals 42. Subtract 12 from both sides. I'll leave S right here, and 42 minus 12 is 30. S equals 30. It looks like sister is 30 years old. Let's confirm that by doing it one more time. Let's substitute 12 into this part right here. S equals 2 times 12 plus 6. 2 times 12 is 24. 24 plus 6 is 30. S is still 30 right there. And as it's a word problem, we should be answering this question in words and do the same thing as we did the previous times. So, wait, what did they ask? What did they ask? How old is Bob? Notice, I didn't have to solve for S here. The question was, how old is Bob? They never asked how old the sister was. I got to it. I did it. But I didn't have to. If you give that information, that's not answering the question. We just got to say how old Bob is. Bob is 12 years old. I didn't have to answer this sister, so I should have looked at that before. I was just assuming. I was going to say, well, look, guys, you know now that we have to write this thing as a sentence, and we got to answer both things. Yeah, make sure you answer the question being asked, and that's the one right here. Bob is 12 years old. Sister's 30, but they didn't care. They didn't care. All right. Word problems? Not really. Joe bought, use the table here. Joe bought 7 pounds of potatoes, X pounds of onions, and Z ears of corn. I forgot they're called ears of corn. I was going to say bunches of corn. What does the expression 0.96x represent? Okay. This is my first time looking at this one as well. So here's what you see. Onions are 96 cents per pound, or $0.96, right? 96 cents per pound of produce right here. X represents pounds of onions. If each pound of onions costs 96 cents, and we're looking at X pounds of onions here, 0.96x is taking two different sets of units here. I know what it is, but I'm trying to slow it down for you so I can work this out. I want 17 to be lower. I keep looking at that. I want number 17 to be lower. 0.96, the units here is dollars per pound. Dollars per pound. Dollars divided by pounds. X is represented in terms of pounds. What happens when you multiply dollars per pound by pounds? This works the same way as variables do. LBs cancel out. The pounds cancel. You're left with dollars. What this becomes is a dollar amount. 0.96 times X represents the amount of dollars you'll spend on X onions. Think about it this way. What if you bought 100 onions? How much are you going to spend? You're going to do 96 cents per onion times 100 onions. That's $96. So here, this equals, why is this red? This equals the total cost in dollars, of X onions. Okay, there it is. Remember, that's multiplication. Right? Julie bought Y pounds of potatoes and triple that weight of onions. What does the expression 0.45Y plus 3Y times 0.96 represent? Okay, so they kind of help you with the triple that weight of onions thing to help you with this. If she bought Y pounds of potatoes, triple the weight, this guy right here is triple that weight of onions. So they're expressing onions not in terms of X this time, they're expressing it in terms of Y. Their pounds of onions this time is represented like that. Okay? That way they don't have to use X's. So it's like they're substituting. So check this out. This is kind of important that I still use this though, because 3Y could have been written as an X, right? If X represents the pounds of onions here, X times 0.96 is 0.96X. What is 0.96X? Well, we've seen it before. It's total cost of X onions. Right there. It's the total cost of all the onions that you have, right? It's triple the amount of the potatoes that you have. Now, the 0.45Y is going to fall in the same vein here. Potatoes, Y pounds of potatoes, they're at $0.45 or 45 cents per. It's going to be the same thing, only potatoes here is going to be 0.45Y plus is going to be total cost. I know I'm not explaining this very well. It's going to be total cost of Y potatoes. So, in total, all of this together, remember, this is the same thing as this guy right here, the 3Y. This is going to be the total cost of Y potatoes, and you could say X or 3Y here, either X or 3Y onions. Either or, they represent the same thing. X is triple the amount of Y. It's probably better you say 3Y there, but that's the total cost of all those ones together. All right, that's what happens when you multiply those and add them together. Okay. And yeah, these are kind of out of order. I would have liked to see these before setting up the word problems where we'd solve equations on our own. All right, numbers 18 and 19. Write each as an algebraic expression. 7 more than twice the number. I'm going to use the number as X. A number I'm going to use as X here. What's 7 more than twice that number? And if you still have problems with this stuff, again, try a real number, make it work. What's 7 more than twice the amount of 5? Well, you take twice the amount of 2 times 5, and then you add 7 to it. So we're going to take 2 times our number, whatever it is, X, we'll go ahead and add 7 to it. There's my algebraic expression for 18. Number 19, the difference of 15 and a number. The difference of 15 and a number, our number is X. What's the difference of 15 and 3? 15 minus 3. What's the difference between 15 and X? 15 minus X. They could have made these problems a lot harder. They could have, if they said 7 less, a lot of people have trouble with this because they do 7 minus. You actually got to do minus 7 because 7 less means you subtract 7 away. All right, that's one of those things. They could have made these harder. Looks like they decided not to. All right, 2 more problems here. Find the solution of this guy. Doesn't look like they want us to graph. This one, solve and graph the compound inequality. We'll get to that. All right, number 20, find the solution of this guy. This is one of those problems. I'm going to rewrite it one more time to give myself some more room. Remember that problem way in the beginning? Let's go full circle here. Remember the problem way in the beginning? I don't even know if it was an inequality. This one right here. Remember when I said, hey, maybe we could divide both sides by 12? Because you can. If something's multiplying on the outside of something, instead of distributing, we might divide. Why didn't I want to divide? 2 reasons. This becomes a fraction, and if I distribute this guy, this does not become a fraction, right? It became a 6. So I didn't want to divide here because distributing was a better option. Well, now, number 20, I don't want to distribute 1/4 into 5x or 1/4 into 2. Those are 2 different fractions. That's not going to help. I'd rather, I guess I'm working here, I'd rather divide, but how do you divide by 1/4? We talked about this. Multiply by the reciprocal. Instead of thinking of this as dividing by 1/4, we're going to say multiply both sides by 4. This can allow me to get rid of the fraction completely. I don't have to distribute. Distribution's gone. 1 times 5x, guys, is 5x. 1 times 2 is 2. So you don't have to distribute. It's just going to be what's left on the inside. -9 times 4 is -36 right there. So now it's a 2-step inequality to solve. I'm going to subtract 2 from both sides. Follow along with me here. 5x is less than or equal to -38. -36 minus 2 is -38. And now divide both sides by 5. Divide both sides by 5. We get x is less than or equal to -38 over 5. Not a fun number. Definitely not a fun number. If you had to graph this on a number line, guys, this is where the mixed number or decimal actually kind of helps. We're not going to graph it, but I am going to give you the equivalence here. 38 divided by 5. 5 can go into 38 as much as 7 times. And then there are 3 left over, because 7 times 5 is 35, plus 3. This is a negative, so -7 and 3/5 right here. As a decimal, that's -7.6 exactly right there. So different versions of that. If you graphed it on a number line, it's between -7 and -8. All right, last one, number 21. Solve and graph the compound inequality. How unfortunate I don't have a number line. I'll do that at the end. I have x plus 1 in the middle, -4 on the left, and 5 on the right. I want to get x by itself on all sides of this compound inequality. So as I subtract 1 from the middle right here, I'm going to go ahead and subtract 1 over here and subtract 1 over here. Remember, it subtracts from all sides. Kind of a weird statement to make, but it subtracts from all sides there. Okay, x is left in the middle. That's all I do there. And then less than or equal to 5. But x is also greater than -4. Remember, if we read this right to left, x is greater than -4, but less than or equal to 5. The way I like to say it as this compound inequality right here is, some people say -4 is less than x, which is less than or equal to 5. That works. I say x is in between -4 and 5. 5 is included in my solution set. -4 is excluded. So number line, how are we going to do this one? This one doesn't have arrows. The number line has arrows, but the solution set doesn't have arrows because, is that slanted? There we go. Because it doesn't go on forever in these directions. I'm between two numbers. I'm between -4 and 5. So let's do this the fast route. Here's -4. Here's 5. I'm going to go ahead and place an open circle on -4 as it doesn't include -4. 5 does have a closed circle. I will include 5 on this set, and x is anywhere in between, including 0. You'll notice I like to put 0 in my solution sets because sometimes I even like to double check my work and see if it works. And I know that I like to test 0. It's a nice, clean, easy number to plug in to equations and inequalities because 0 plus something is just itself, and 0 times something is 0. And that always tends to help a lot. All right, so that was the last problem, and that ought to do it for this here, guys. And I know that that was a long set, an hour, 13 minutes here for me on my end. This is Mr. Robinson. A lot of questions taken care of, but I hope that you learned some things along the way. It's probably too late for me to say check the description section for timestamps, as well as there's a PDF of this thing below, but I might as well say it here in the end, just in case you go back and watch it again for any particular reason. All right, if you have any questions, please leave some comments down below and ask a question that way for me. I will greatly appreciate it, and I will happily respond to your question. Sorry for it being so long, but hey, that is how it works. And by the way, for my students, think about this for my students. This was long, right? I guess it was long. This was an hour 13, okay? An hour 13. Your class is an hour 30. You have the same kind of test. You have 21 questions. It's going to look the same as this. It'll have different numbers and things like that. I finished this test with about 20 minutes to spare. I finished this test on time. If I had to take this test for myself, I still finished on time. Okay. And I did extra graphs, and I found multiple ways to solve a problem, and I showed mixed numbers and decimals, and I explained the heck out of everything. And I'm not saying, therefore, you should be able to do it in that time. No, I was actually going to say it the other way. I was going to say, be mindful and, I guess, relieved of the fact that 21 questions you can probably do in decent time if you know what you're doing there. So have confidence in these guys. Understand that even if you go slowly, you'll have some time there. And hope that makes you feel a little more comfortable. Okay, take care. Have a good one.